spacecraft is now crossing the solar system toward a moon that may have more liquid water than Earth. That moon is Europa, one of Jupiter's icy worlds. From the outside, Europa looks frozen and hostile, but measurements from earlier spacecraft strongly suggest that beneath its cracked ice is a global ocean, kept warm enough by Jupiter's gravity. Squeezing and flexing the moon, NASA's Europa Clipper is built to investigate that possibility up close. After launching in 2024, it began a long cruise toward Jupiter, where its most important science will come from many brief encounters with Europa. It is not a lander, and it is not a mission to announce life. Its job is more careful and in many ways more powerful to ask whether Europa has the ingredients that could make life possible. Scientists already think Europa has three important pieces: water chemistry and energy, but the details are still uncertain. How thick is the ice? Does material from the ocean reach the surface? Are there pockets of salty water closer to the top? These are the kinds of questions Clipper is designed to explore. The mission matters because it changes the way we search for habitable places. For a long time, Earth seemed to suggest that sunlight was essential. Europa reminds us that warmth can also come from gravity, and that oceans may hide beneath ice in the deep outer solar system. This is why engineers and scientists find the mission so compelling. The spacecraft must work near Jupiter's intense radiation, far from the Sun, while collecting clues from brief passes over a world it cannot touch. The memorable takeaway is simple. Europa Clipper is not going to prove there is life on Europa. It is going to test whether Europa is the kind of place where life could ever have had a chance. And that question leads directly into how a mission can study an ocean. It may never see. Europa Clipper will study a hidden ocean without ever diving into it. That sounds impossible, but spacecraft often learn by reading traces. Europa is covered in ice. If the ocean below interacts with that ice, or if salty material reaches cracks and ridges on the surface can become a kind of frozen message. The spacecraft's plan is to orbit Jupiter, not Europa itself. That choice matters. Jupiter surrounds Europa with harsh radiation, and orbiting the Moon directly would expose the spacecraft for longer. By looping around Jupiter, Clipper can make repeated close flybys of Europa, gathering data during each pass, then moving away again. During those flybys, its instruments study the Moon in different ways. Cameras can map the surface and look for places where ice has shifted, broken, or possibly been renewed. Spectrometers can examine what the surface is made of by reading reflected light. Radar can send signals into the ice and listen for echoes, helping scientists estimate structure beneath the surface. Other instruments can sample particles and sense magnetic fields around the Moon. The simple idea is this: no single clue is enough. A cracked landscape might suggest movement, but not explain what drives it. A chemical signal might be interesting, but need context. A radar echo might hint at layers, but still require careful interpretation. The mission becomes powerful because all these clues can be compared. What is known is that Europa is very likely an ocean world. What remains uncertain is how accessible that ocean is, how the ice behaves, and whether the chemistry is friendly to biology. Clipper will narrow those uncertainties. This matters beyond Europa. If scientists can learn how to investigate an ocean under ice from orbit, that knowledge helps with other icy moons too. The takeaway is that exploration is not always about landing. Sometimes it is about passing by again and again, patiently building a portrait from shadows, signals, and chemistry. And those clues lead to the biggest question of all. What can this mission actually prove? The most important thing to know about Europa Clipper is what it cannot tell us. It is not designed to scoop ocean water into a laboratory. It is not expected to photograph living organisms beneath the ice, and if it finds promising chemistry, that still would not be the same as finding life. That may sound limiting, but it is exactly what makes the mission scientifically strong. Before you search for life, you need to understand the place. Is there a long-lived ocean? Does the ocean communicate with the surface? Are the chemical ingredients useful? Is there enough energy to drive reactions that living systems could use? Europa Clipper is built around those questions. Its results will help scientists decide whether Europa is merely interesting or one of the strongest places in the solar system to investigate further. A future mission, still only a matter of planning and possibility, could one day land drills sample or focus on a specific region. Clipper helps choose whether that next step is worth taking. The most important factual update is also the quietest one. After its 2024 launch, Europa Clipper is on a long journey toward Jupiter. The mission's major science phase is expected after it arrives in the Jupiter system, planned for 2030. Space exploration often moves at this pace. Years of travel come before the minutes and hours when the best data is gathered. What is known today is that Europa has strong signs of a buried ocean. What is uncertain is whether that ocean is habitable in the full sense, stable, chemically rich, and connected enough to the surface for a spacecraft to read its story. That uncertainty is not a weakness. It is the reason to go. The memorable takeaway is this: Europa Clipper is a mission about possibility, not proof of life. It is humanity sending a careful question across the solar system. Could an ocean hidden in darkness still be a place where biology might begin? And until those answers arrive, Europa remains one of the most compelling worlds we have ever dared to investigate.